Hokie dokie. Welcome to 1014 Quiz 5 review session. It's going to be a quick one, maybe 30 to 45 minutes. There's not much going on in Quiz 5. This is going to be available for You Will Get an A and higher members. If you are looking for quiz reviews for other courses, 1524, 1025, or 1026, they have already been posted last semester. They're, I live streamed them originally, and the recordings are uploaded. So find those in the playlist, the quiz review playlist. There should be a quiz review playlist for each of those courses. So we're going to jump right into it as soon as I can make sure this is all good to go. We're going to jump right into it as soon as I can make sure this is all good to go. Jump. All right. Let's get started. Oops. All right. Welcome to Math 1014 Quiz 5 Review Sesh. Let's jump right into it. We only have like 10 to 13 problems, something like that. It might even just be like 10. Starting with question number 1. They say, which of the following contains all of the intervals where the graphs of f of x lie below the x-axis? Okay, so they say, which of the following contains all the intervals where this graph lies below the x-axis? So we're trying to figure out if we were to graph this. Basically, I'll just give you a rough example here. So if this graph, say, did something like this, we're trying to find all the intervals, all the locations where it's below the x-axis. So there's a couple different ways you could go about this. We could take the factoring route, which I'll probably show you how to do. We could also do sort of a graphing in Excel kind of route, and that might be a little easier. It'll help because it's like a little more visual. Yeah, all right. Let's start with factoring. So how can we factor this? Looking at this function, if we're trying to first find where it's equal to 0, because that'll give us an idea of what the x-intercepts are and help us construct our intervals a little bit better. We're going to set this equal to 0. We're going to start by factoring by pulling out a greatest common factor. So not just x cubed, but I would recommend factoring out a negative x cubed so that what is left is a positive x squared minus 6x and then minus 16. And so from there, we have negative x cubed, and then we can factor this quadratic expression into two smaller factors, two linear factors. We need two numbers to multiply to negative 16, but to add to negative 6. So that would be minus 8 and plus 2. Excuse me. So what do we get from these? We set each of these factors equal to 0. So if we set an x cubed or negative x cubed equal to 0, the only x value that would make that equation true is x equals 0. We set x minus 8 equal to 0. We add 8 and we get x is equal to 8. And then we set x plus 2 equal to 0. Solve for x by subtracting 2. We find that x is equal to negative 2. So what does this mean? This means on a graph at negative 2, 8, and 0, this function will pass through. It'll intersect the x-axis. And because this graph is a negative x to the 5th graph, it's a negative odd function or an odd negative function. Odd negative the function will start in the upper left and then it'll end in the lower right. This is known as its end behavior. So if you're not familiar with end behavior, I would recommend checking out the original video that I have posted for 231A. I think I go more in depth. Just to do it roughly real quick, odd negative looks like this on both ends. Odd positive would look like this. I'll go ahead and just do them all. Why not? Even positive, think about the graph like positive x squared. It would be opening up like that on each end, and then even negative would just be opening down in both directions. Okay. So anyway, so we have an odd negative function here because we have an x to the fifth graph and it's negative, and so it's going to be opening up to the left and then going down to the right from our furthest left and furthest right x-intercepts respectively. So we're passing through -2, we're passing through 0. Something random to mention about 0 is that it's going to be passing through the x-axis at 0, but it's going to be passing through in sort of a squiggle or a cubic like manner instead of just passing straight through, and that's on account of the x being cubed there. So then it passes through regardless, and then it comes down eventually to x equals 8. So what does this tell us? This tells us that, think about what we're looking for here. Where does this graph lie below the x-axis? It lies below the x-axis from, let's get a little highlighter going, from -2 to 0, and then from 8 onward. In other words, 8 to infinity. And so, which interval is from -2 to 0, and then from 8 to infinity? That looks like option E. And we're done. So I'll just leave it at that in terms of process. So factor, plot your x-intercepts, figure out which end behavior you have, and then do a little sketch of that graph, and then identify the intervals where it's below the x-axis. Again, you could take the approach of graphing that in Excel or in Desmos, and then just see for yourself what the graph looks like, get the intervals like that. Yeah. All right, let's go on to number 2. They say, which of the following functions describes the graph of x squared shifted 4 units to the right and 8 units down? So here's a little intro in transformations. When we're just talking simple translations, like so many units left or right or so many units up or down, here's how we go about that. We treat it as x minus something squared plus something. And so minus h is describing the shift horizontally. So anytime you see some situation going on like inside parentheses where it's like x minus something or x plus something, that's describing a horizontal shift, left to right. So to shift 4 units to the right would look like this: x minus 4 squared, because we're going 4 in the positive direction, and the trick sort of is do the opposite of what it looks like you're doing in the parentheses. So x minus 4, you would think we're going in the -4 direction, but we're actually going in the +4 direction, or 4 units to the right. And roughly a reason that is the case is because when we plug 4 in place of x, we get 4 minus 4, which is 0. And so it's like we're always shifting in the direction of the x value that makes the parentheses equal to 0, roughly. So anyway, x minus 4 is to the right. Had it been x plus 4, that would be 4 units to the left. Okay, so this is our horizontal change, h. And then k is our vertical change. And k is a little more intuitive. It's more direct. If you say plus 8, that means we're going up 8. And if we say minus 8, that means we're going down 8. And we want to represent 8 units down, so we are going to subtract 8. And I guess they want to call this g of x, so we're going to call it g of x. X minus 4 squared minus 8, and that is option A. That's all there is to it. So horizontal shift, vertical shift, anything inside the parentheses, do the opposite. Anything outside the parentheses, it's like not the opposite, it's just more direct, more intuitive, whatever. All right, that was number 2. Let's do number 3. Big jump in difficulty here. I'll try to explain it as best I can. Which of the following operations on this function, or on the graph of this function, would yield or result in this graph here of g of x? They're asking what transformations would happen to f in order to get g. The way I'm going to approach this is first by rewriting g. I want to make g match the form of f of x as much as I can, and currently it does not look like f of x at all. So the quick way to rewrite g is by dividing each term up top by x. When we do so, the x's here cancel, and we're left with just -7 minus 1 over x. And if we just rearrange this, we get -1 over x minus 7. And what you might be able to see is like, oh, okay, well the original function was 1 over x plus 3, and now this is -1 over x minus 7. And so you can kind of see at least some like connection with the 1 over x, and then originally there was some transformation, and then here it's a little bit different. I don't know. So once you get it in this form, the next trick I would say with this one is just look for the vertical shift. The vertical shift will usually tell you the answer. The shift here, notice how the original function didn't have any like +5 or -5 or like anything on the outside of the 1 over x piece, right? It's just, you know, just 1 over x plus 3. So there's originally no vertical shift occurring. But on the new one, there's a -7, meaning the original function got brought down by 7 units. And the only answer that says that is option B. And so I'll explain why B is our answer, but again, just always go with the vertical shift. That seems to work out every time. So starting with the original function, I'm going to perform the transformations described in in answer B and just show why it gets us the function G. So first thing is shift down 7 units. So to shift down 7 units, again, we would simply subtract 7 on the outside. Now, next step, reflect over the y-axis. To do so, we just negate x, and that's it. We just say we replace x with -x or -x. That's it. Next step, they say finally translate left 3 units. So what does it mean to translate left 3 units? That means we're going to replace x with x plus 3. Keep in mind we're going left. We are going in the negative direction by 3, which means we want to add 3 to the x. It's like doing the opposite, right? But we still have the plus 3 right there. So again, what I've done here is replace this x with x plus 3. That's translating 3 units to the left. Okay, so then we still have that -7. Now let's simplify this. If we simplify this, what do we get? We get 1 over. If we distribute the negative, we have -x minus 3. And then on the outside, we still have plus 3. And then we still have -7. So on the bottom, -3 and plus 3 cancel. We're left with -x minus 7. The negative with the x can just be brought out in front. So really it's like -1 over x minus 7. -1 over x minus 7. So we just showed that making all those transformations gave us the g of x function, how we had rewritten it before. Okay? So definitely one of the harder problems in this section, but do the best you can. If need be to, do the best you can to rewrite the g of x function. Identify what the vertical shift is, and hopefully that'll identify the answer or help you identify the answer. Don't worry about all this proving stuff. That was just, for my sake to show you how B worked out. Okay, that was number 3. Let's do number 4. The problems will pick up from here. I promise they'll be much faster. All right. Which of the following equations describes a parabola? So, a parabola as we know it right now might just be y equals x squared, or even x equals y squared. But what you will never see is x squared equals y squared, or y squared equals x squared. You don't want to look, you don't want to find an equation that has both terms squared. So for example, option A with both x squared and y squared, there's no way that's going to be a parabola. Option B, it's looking promising. Option C, potentially. Option D has both y squareds there. So, as x squared and y squared. So we get rid of that. And then I realized that C, what's wrong with C? C actually only has x terms, but there's no y. So there's no, real equation. It's more of just like I don't know. There's no like two variable relationship. It's just a single variable. So I'm going to eliminate that too. We're looking for just some sort of y with an x squared or x with a y squared. And so that's going to lead us to option B. And we eliminate all the others. Yeah. All right. That was number 4. Let's do number 5. They say, which of the following is the graph of this parabola? Let's talk about the first thing I notice. That is the leading term, negative 2x squared. The x squared term is negative. And so the graph of the function should be opening downward. It's a parabola that's opening downward as opposed to opening upward. So we've narrowed it down to A and B. And what's the difference between A and B? What do you notice? The vertex for each of these graphs are at different locations. This one's at about 2.5, x equals 2.5, and the vertex for graph B is at about x equals negative 2.5. So how do we find the x value of the vertex? Well, we're going to use this nice formula, negative b over 2a, and that will find us the x value of the vertex of any quadratic function. A quadratic function of the form ax squared plus bx plus c, or y equals ax squared plus bx plus c. So what is our b in this case? Our b should be next to the x, so negative 10. So we have x equals negative, and then b is negative 10, and then divided by 2 times a, and a is next to the x squared, so negative 2. So we have negative 10, which is positive 10. 2 times negative 2 is negative 4. We divide those, we get negative 2.5. And that tells us our vertex of this parabola should be at x equals negative 2.5, which leads us to option B. And that's all there is to it. So had it been a positive x squared graph, we know that would be opening upward, and then again negative b over 2a will help you find the vertex. It'll find the x value of any vertex. All right, that was number 5. Here's number 6. Number 6 says, which of the following equations describes the parabola whose graph has its vertex at 1, 0, opens left, and contains the point blah blah blah? I'm going to say ignore everything except for opens left. Let's talk about this a little bit. We know that y equals x squared opens up. Y equals negative x squared opens down. Likewise, x equals y squared opens in the positive x direction, which means it opens right. And x equals negative y squared opens in the negative x direction, which means it opens left. We're looking for the graph, or the equation of the graph that opens left. So we're looking for an x equals a negative y squared. So first of all, we want to see a y squared and not an x squared. So we can eliminate any that have an x squared instead of a y squared. Now, we want to think about between c and d, if we were to solve for x, which of these would have a negative y squared on the opposite side? So what I would say is basically ignore the constant and just think about if you got x by itself in these equations, would you have negative y squared on the opposite side of the equation? So in this case, for equation C, if I added x over 2 to the other side, hopefully you can see right away that like we have x, some sort of x equals a positive y squared instead of x equaling a negative y squared. Even if we multiplied by the 2 and got an x by itself, it's still just a positive y squared term. But for D, if we subtract the y squared, we have x over 2 equals negative y squared. Even if we multiply the 2 over, we'd still have a negative y squared term, and that's what we're looking for. We're looking for some sort of x equals a negative y squared. Okay? So D is our answer here, because that is the equation when rearranged that would produce x equals negative y squared, or some variation of that, I guess. And we're looking for that because it opens left. All right. So again, this would be x equals y squared would be opening right. Negative x squared opening down. Positive x squared opening up. Yeah. All right. That was number 6. Here's number 7. I think I did another version here. Again, ignore that. Focus on how it's opening. So that would be y equals x squared. And so we're looking for an x squared, not a y squared. And so then if we focus on just the x squared and the y terms, if we got them on opposite sides, for this one we'd have x squared equals 2y. That's looking promising. But then for this one, it'd be x squared equals negative 2y, or even negative x squared equals 2y. And so this would be opening down because it's a negative x squared. This would be opening up because it's a positive x squared. So we're going with option A. All right, that was number 7. Excuse me. Here's number 8. They say, which of the following equations describes this graph? Now, what is this graph of? What's the figure? Yeah, it's a circle. Okay. Where's it centered? Well, it looks about 1.5 or 3/2. And then it goes down about 3, so -3. So its center is at 3/2, comma -3. And considering the circle, what's its radius? How far out are we going from the center to any edge of the circle? Just looking at the vertical change there, it's going from -3 to -1, so that's a radius of 2. So radius of 2. With this in mind, I'm going to give you the equation for a circle. X minus h squared plus y minus k squared equals the radius squared. So h and k are the location of the center. They're the x and y values respectively. R is the radius. So if we just plug everything in, plug in 3/2 for h, plug in -3 for k, and 2 for r. We have 2 squared. 2 squared is 4, and then subtracting a -3 would be adding 3. So we're just looking for this. So y plus 3 only shows up in option D. So that gave it away, but everything else matches as well. All right. So identify your center, identify the radius, use your circle equation. HK is the center, R is the radius. That's it. All right. That was number 8. Here's number 9. Which of the following equations describes a circle? So again, for a circle, you want positive x squared, positive y squared. I'll go ahead and say you want the coefficients of x squared and y squared to be the same. So if you see a 1x squared but a 2y squared, that's going to lead to some sort of ellipse, most likely, not a circle. X squared and y squared looking pretty good. X squared minus y squared, that would lead to some sort of hyperbola. We don't want positive and negative values. And then between these two, I think the shortcut is, let me see if I can get this right. I think you want to, so the only difference between B and C is the constant on the end. You want that constant to be as small as possible and negative if possible. So in this case, we're going to go with -2. Yeah, I think that's right. So that's leading us to option B. And it has to do with, like, if you were to complete the square for these and like basically rewrite this equation, B would work out and D would not, because what would happen is if you rewrote D and tried to get it into like the x minus h plus y minus k squared equals the radius squared, what would happen is because you have a positive number here, once you move it to the right side, it's going to be some negative number. And then especially like once you complete the square, you might even add like a 1 or a 2 or something on top of that, but it's not going to be enough to make it a positive value. So the main idea is like you would have this circle is equal to some negative number. And that can't be the case when you're supposed to have an r squared. R squared would always be positive. So like if you have a negative number on the right side of the equation, that's going to be an issue. And so that's why we always want to choose the negative value, the smaller of the two constants, because if it's a negative while it's on the left side, once you add it over, it's automatically positive. And so you don't have to think about like, is the result going to have a positive or negative on the right side? And so, yeah, always go with the smaller of the two constants on the end once you narrow it down to the equations that have x squared and y squared. All right, that's the short version. Let's go on to number 10. Number 10, they say, which of the following equations describes a circle with center 8, 4, and radius 4? Keep in mind our equation, just x minus h squared plus y minus k squared equals the radius squared. So right away with the radius squared, we should have 4 squared on the right side, or 16. So we can eliminate any that don't have 16. And then, which of the parentheses has x minus h, so x minus 8, and then y minus 4. Each of those are squared. Hopefully it's not too crazy. That's just option C. So x minus 8 squared plus y minus 4 squared equals 4 squared. That's all there is to it. All right, I think we just have 2 more here. This is number 11. Let's check it out. A man decides to walk around the block, a rectangular block, to get a little exercise. He lives in the middle of the block, which is 260 meters long. The cross street block is 50 meters long. He has a cordless phone with him, and he's wondering what the range of it is. Which of the following graphs represent the direct distance, or as the crow flies, from him to his home if he walks, at a constant speed of 1.5 meters per second around the block and back home? So there's a couple different ways to go about this, but I'm going to go with the fastest way here. So got a rectangular block. Again, his home starts in the middle of the block. So he's starting right here. So I'll just do a little something like that, right? A little home. Put a little door on there. Yeah, okay. So he's starting in the middle of the block. He's walking around. And he basically, these graphs, or whatever the correct graph is, should represent the distance from the house, like as the crow flies. So if he's like over here, the distance will be from here to there. And if he's right here, the distance will be from here to here, and so on. And so the trick to go about this one is think about where he would be halfway through that walk. If he's walking at a constant speed, where would he be halfway through that walk? Well, halfway through that walk, he would be on the opposite side of that block. So he's going to spend 50% of his time walking here and then there. So right here, about halfway through that walk, he should be directly across from that house. He should be this distance from end to end away from the house. And they tell us that the cross street block is 50 meters long. So that distance halfway through should be 50 meters of distance, or 50 meters long, whatever. So what I'm saying is, look at the middle of each of these graphs here. And which middle has a distance of 50? Graph 1, or graph A, has a distance of like 150. Graph C here, maybe like 125. Graph D, maybe like 80. But graph B, spot on for 50. So that's my trick for this one. Just look at the halfway point and just, know that it should be the distance of the cross block. You don't have to draw this every time. Just know that halfway through, the y value on the graph should equal the cross street block distance. Okay? Or length, whatever. That was number 11. Let's finish with number 12 here. They say, The population for a certain town is increasing for 8 years, but not at a constant rate. For the first 4 years, the rate of growth is increasing. After that, the population grows at decreasing rates for the rest of the time. Which of the following graphs describes how the population depends on time t? Okay, so they tell us that the population is increasing for all 8 years. So it's increasing, meaning it should have some sort of positive slope. If it has any negative slope, let's get rid of it. B has a negative slope. Let's get rid of it. C has a negative slope. Let's get rid of it. A and D are definitely increasing the entire time, but at different rates, right? So they tell us for the first 4 years, the first half, the rate of growth is also increasing. So the population is increasing at an increasing rate. It's almost like going up a roller coaster, going up a chain lift or whatever it's called. You're starting a little more flat, and then over time, you start ramping up, like going up a skateboard ramp, whatever you want to call it. I don't know. So increasing at an increasing rate should look like that, also known as concave up, if you want to think about it like that. So you're starting flat, getting progressively more steep. So that's increasing at an increasing rate. And then if you're increasing at a decreasing rate, sometimes it's hard to think about, but think about you're starting at a steep increase and then flattening out. Starting at a steep increase, but then flattening out would look like this. So again, I'm going to just write decreasing or dec for decreasing, but what I mean is it's decreasing at it's increasing at a decreasing rate. So I'll just say increasing rate, decreasing rate. Okay? Anyway, so in the first half, the first 4 years, it's increasing, and then the second half should be decreasing. So we're looking for something that starts like this and then goes like that, and that is option A. All right. D would be if they had said decreasing in the first 4 years and then increasing in the second 4 years. Okay? All right. Very good. So that pretty much wraps up this Quiz 5 review session. Thanks for checking it out. I will scroll through everything now. If you have any questions on anything, just let me know. Good little intro into functions and factors and behavior of functions and transformations of functions. A lot of good stuff here. Parabolas, circles, quadratics. Lots of good stuff. All right, that about wraps it up. Thanks for watching. If you have any questions going forward, as always, feel free to send them to carterdeeemath@gmail.com. I'm always happy to help. All right. Thanks so much for watching. If you have questions, let me know. All right. Bye-bye.